Hi, Davy here. Today we're going to talk about pattern matching in functional programming using TypeScript. So, during the last few videos, I've been covering this idea of composition techniques in functional programming. I've shown you a few examples. If you watch till the end of this video, I put some links at the end where you can actually watch the previous one. They're really interesting and it gives you a good insight on how you can make your code really easily maintainable by using composition technique. That said, today we're going to talk about design pattern matching in functional programming. The example I'm going to use here, start from the book here. Hey, first, get out of the way. We're going to move myself out of the way here. And we talk about that example right here. So the pattern matching is this idea of like you have in pure JavaScript a simple object with certain property inside, and based on these properties you want to be able to implement some logic that basically apply to any kind of element that follow a certain shape, right? In JavaScript, everything is an object, so there is a shape that you can follow. You can use actually to construct object so that a function can actually be used to apply certain rules on different objects that follow a basic concept. So this is a little bit abstract. The example you see here comes from the fantastic books from Remo called Functional Programming Techniques with TypeScript. Let's go into the code so I show you a little bit what we can do here. Okay, so again, I'm on the way. I'm gonna put myself here so you can see exactly what we're writing right now. So let's write a little bit of code. You see here we have a shape kind, a circle, a rectangle, and a square. These are possible shapes, right, that you can have. Keep in mind that we only selected 3, right? I'll come back to it a little bit later, and toward the end I will show you how you can actually leverage some powerful technique in JavaScript to make this code really easily maintainable and easy to actually compose things with, right? So we have these 3 shapes, and here we define some TypeScript shapes that represent, well, these 3 shapes. And now with TypeScript, one of the things you can actually do is you're going to create a shape, a type that will basically be like a union of these 3 things, right? So it says you can say circle or square. We say square here, or rectangle, right? So it's basically these you have now a shape. Now, one of the questions I ask during interviews at packages, I ask people, hey, here is this format. Could you create for me a function that calculates the areas of each of these shapes, depending on the object, right? Or even regardless of the object you receive, it has a shape and you would like to calculate the area. And then people be like, well, first, that is not really the job you're gonna be doing. That you're not sure about it. It's not about really calculating areas. You will need that if you build things like video games and things like that, or even some complex UI animation you will put in place. So it could come handy at some point. So the point here is do it, implement that. Just do it, okay? So how do you go about it? Well, the way you go about it, you say, I'm gonna create a function called area calculator. Right? And that function, if I write it well, function here. And what is that function doing really? It's going to take one of the shape, right? So here we're just gonna say shape, and we're going to pass the shape right there. And what you see there is the fact that we just pass one of these 3 shapes right here, and we should be able to pass any of them here. So then I see people go this way. They say if the shape dot kind is equal, and then they start going like a circle right here, because it's one of the option. They put some logic in there, and so on and so forth. So right there you start getting into a multiple if scenario. Here's a little thing. You don't do the if, right? You know, here you can actually use a quick switch. So let me use a quick switch here, and then what you will do with switch, you're gonna say, okay, based on the on the shape dot, and you see right away you have on line 18, it basically you can think of it as the, an intersection where it's gonna select the common dominator, meaning that the property that comes back in each of these things will be the one that will be right here. And from that point on, you can basically say the selection, the switch, instead of putting multiple if, you can actually just put just the kind right there, and then the kind will be either a circle, a square, or a rectangle, right? Then you have to just handle each of the case, right? So you go shape kind is circle. You gotta say, okay, the circle, for example, what do we have? We know that from the moment we say circle, right below, so it's that concept here as a name. It's like a type narrowing, something like in TypeScript. I will put it in comment. I actually did a video about it a few months ago. Now that I said that the shape is a circle in that scenario, it shows me radius, but why isn't showing me the square size or the rectangle? Because at that exact moment I'm in and I'm gonna put some curly braces here. I'm basically in a block that says here we only dealing with circles. So there is no way you're gonna have anything else than the kind and radius. So once you do so, you can then say the radius is like that. So if we just remove this for now and then go here and say function, we call area calculator, and then we want to pass basically a shape here, and we're gonna say kind, and then we say shape kind is a circle, and then we're going to say radius is, let's say, 50. So if we did it well, we should basically have 100 right there, right? This is working. Now obviously this is not enough. We have to handle some other possibilities here. So what happened when we have a rectangle right there? So with the rectangle, you see right away, from the moment I write rectangle, I have an error. It basically complaining there is no radius in rectangle. So rectangle here, we're gonna have the height times shape dot the width, right? Right away you see how the pattern matching is using the TypeScript is basically leveraging that idea of pattern matching to help you implement a really focused scenario right there. Hey, stay with me, because what I'm showing you here, it's cool, but there is a way to make this code even easier to maintain. Because keep in mind, and I mentioned that at the beginning of the video, keep in mind that now we're talking about only 3 possible shapes. Look at the world around you. Look around you. There's so many other type of shapes that list here could go to 50 plus different shapes. And if you only have one function handling each of the area calculation, you might be in writing some function that are difficult to maintain, right? So here, let's just finish with that, and we're gonna handle the case when we have access to a square, which is in, once again, there is no height and width, and this case we're gonna have the size, and then we just gonna multiply the size time by itself here, and then we should have this one calculate for the circle, and then rectangle we can just give a different information here, the width and the height, and then we basically say 40 15 here, and then we see as we go everything is working really well. Now and then you gotta don't forget to handle the break. But I'm gonna show you a quick tip in the tip app. You can go there and find it. That can make sure that if you forget about the default, TypeScript is gonna yell at you, so that you don't forget the default here, right? So let's quickly add a hierarchy calculator for the square. And for the square, what we're going to do is to say the size, that's what we have here, and square we're just gonna say 50, and we should be good right there. Okay. So now let's do some cleanup here. I hope this is pretty clear for you. You see, you understand how that from a certain type here, you can actually handle really complex operation using pattern matching. Now, this is all cool and dandy and so on and so forth, right? Now, in the next step, I'm going to show you how this code there that looks quite okay could be improved so that this function isn't basically tied to multiple implementation within the same thing, and we can still achieve the same result, right? So here is a little thing. Now, from here, that function is handling multiple scenario. What we're going to do is we're going to split each of the scenario into its own thing, and then based on that, we're gonna make sure that each of the area has, in a way, its own implementation and could be independently tested, and so on and so forth. So how do you do so? What we're going to do first is to say we're going to create like an area handler. I'm gonna call that area handler, and it's just gonna have it as an object, a simple object right there. And the way I'm going to do that is to say, when the shape kind is circle, I'm gonna create a function, right? And that function there is gonna take a shape, and that shape is a circle, period. That's all it does. And then I do exactly the same thing for a square, which means that here we're just gonna use a square, and then same thing for the rectangle, right? And we're just gonna pass a rectangle here. So what you could see here is basically the it's just three functions, right? The syntax you see right there makes it like easy to use what is happening right here. So the secret here to use it in a way as a constant, right? You can think of it that way, that here we're using a constant. So instead of here going and saying, let me add a circle here, this way, I'm just using that the shape kind dot circle, and that's gonna return circle, but it's like using a constant behind the scene. So let's bring back here, right? So once we're here, we can then take each of these implementation and then move that right here. So that's the first one, right? And then we have the second one, which is the square. So let's go right below. Where is the square? Square is here, and we're going to add that over here. So that's the square, and the rectangle right here, we're going to do the same thing. So where is the rectangle is right here, and we're just gonna go a little bit higher here, and then do this, right? So this is basically the handlers, right? I will call that area handlers, basically. So it's basically a set of functions. That's all they do. So they're going to replace, literally, they're going to replace everything we have right here below. Let me just comment out this right now. So you see, if we look below, all the things are just saying undefined because we don't have the implementation anymore. So how do we go from, where do we go from here? Let me remove this to just get a little bit of space so you see exactly what is happening. You there with me? Yeah? Okay. Look at this. Here, what we're just going to say is, we're going to check, so we're gonna create a handler. That handler is basically one of these three functions, right? It's basically one of these three functions. And what we're going to do is to say area handlers, and we're going to check based on the shape.kind, right? So we're basically checking, saying, hey, is the shape.kind handler shape.kind exist, right? If it does, what we would like to do is to say handler, if you exist, then call area handler. So we're gonna call then that handler, and then we're gonna pass the shape, and then if we don't, if it's there, so if it's there, we just call it, and if it's not there, what we would like to do is to say we just want to, for example, say a new error or something like that, right? So we see now that everything is working again right below, and now here is just complaining, but we can just put it this way, and it should basically be okay. But then, as you can see, now I have each of these things here is its own function. It is basically, its own function. It could be moving to different files, being tested and in isolation. But then you're still leveraging, in a way, at this line, you're leveraging this idea of pattern matching to get the right implementation, and then you go here, call it, and then you have it working really well. Got it? Okay, so let me ask you this. I'm here. You see me? Very good. So if we go back to that implementation here, you can understand that what I just shown you here is all about composition techniques. The 3 videos below are basically other ways to use composition technique to make your code much better. So click on one of them and keep learning, and don't forget to subscribe. See you next time.